All right. Today's going to be a little bit more of a short one, and it's because a lot of the concepts carry over. So let's just go ahead and start talking about NoSQL injection. Um, NoSQL or NoSQL, as I'll be calling it for most of the video, is just referring to databases that don't use traditional SQL syntax. So they might do that for a variety of different reasons. So this is just kind of those edge cases. For the purposes of this presentation and video, we're just going to be going through MongoDB stuff just because it kind of makes it a little more comprehensive. Not to say that's the only thing that's there, but it's common and it's what I found the most resources on, especially when looking for like payloads and stuff. So what is it? It's about the same as any kind of, it's really similar to SQL injection. It's just if you're able to interfere with a query that's being sent to a database, that would be considered NoSQL injection. And just like other injection type attacks, you'll, have issues with authentication bypass and potential data exfiltration. And because we're editing databases, potentially that means there's read and write, and even deleting files that could be possible. And even code execution if the circumstances are lined up that way. So let's just talk about one of the two types that are defined. One of them is syntax injection, and syntax injection is basically like it's basically just kind of like the natural step of SQL injection, except you're not allowed to put in your own clauses. So you have to kind of assume that a clause is being done somewhere else. So detecting injection would mean you kind of have to, if this, is being passed in the URL, you might have to intuitively figure, okay, well, this is the query that's being used on that. So that would be, kind of like detecting those things. And then determining it would be, maybe you throw in some inputs that would throw off the parsing of this value. And maybe that's just enough to get you to figure it out, but you'll want to confirm it anyway by trying to inject some kind of true or false statements so that the responses that are given when you try to submit that query are varied, and maybe those true or false statements are evaluated. You can also exfiltrate data with this. That's what this example is about. So in this case, we can look up a coach by their name. This is what we assume that query might be, how it might be doing that. It'll use the where operator, which we'll talk about in a little bit more detail in a second, but it'll say where this coach name is Kate Burke. That's probably what the query looks like once it's filled in. So we could modify our input to just have, the single quote to break out of that. And then to also include, and this dot password. So probably the password for the given user at the index of 0 is a and, or not and, or false. So it should return false if the password doesn't start with A and true if it does. So you could use that to slowly but surely brute force, the contents of the password by just iterating this array each time you get one right. So that's an example of, albeit very basic, how that might work. Next, we'll talk about operator injection, which is basically, if you're allowed to actually manipulate parts of the query, or moreover, not just parts of the query, but you're allowed to have your own operators be used. So like the where operator matches documents, let's use some JS. Any is just not equal to. In matches values in an array, and regex just selects documents that, match the regular expression. In this case, if it's like a login functionality, right, you got a username and a password that are being submitted. You might be able to just say, okay, well, I'll just put in my own operator here and say username is not equal to nothing, which is always going to be true because you don't want your username database to have null fields. And, the password is this. So if there is a username with this password, you could effectively just do some password spraying. It'll return it'll return true for, all the usernames that have this password. Or if you want to do some authentication bypass, you might be able to just say, okay, well, the username is not nothing and the password is not nothing, which, is going to be true for every single user in the table. So in this case, it would just log you in as, the first user in that table if it's vulnerable, which is kind of a big deal. Next up, we're just going to go straight into a lab. So HTB Mango is a medium machine from 2019. It's got a pretty solid example of this. So we'll just jump into that and then we'll come back here and talk about prevention. All right, so I've got the Mango machine from HTB pulled up here. And you do some subdomain enumeration after you do some initial stuff. Then you'll find this one called staging order. .mango.htb, and it's just a login page. If I turn off my intercept for a second and just try to log in, you'll notice that a wrong login doesn't actually give us any like incorrect username, incorrect password stuff. It doesn't tell us anything that immediately tips us off. It doesn't seem like the website is using some like blatant, library that we can abuse, stuff like that. Forgot password. I actually didn't look. Oh, great. It doesn't even work. No wonder. Anyway, so it doesn't really tell us that much information, but we could imagine, right? If we logged in, it would redirect us to like a home page or something. So I'm just going to go ahead, make sure that my intercept is turned on, and try to log in. And you'll notice, right, it gives us a 200 OK, exactly what we expect. And we can start just trying to, mess around with this application. Now, what I did the first time I did this was I knew, because I looked at the machine prior, I knew that it was going to include NoSQL injection. So I just jumped immediately to trying to, okay, I'll change the content type and I'll change, these other things. And that's fine if it's, already submitting it in JSON data. But, this also, even though it's not being submitted in the URL, the payload kind of looks like something that would be in a URL, right? Like, or at least this post, the body of this post request here. Let me go ahead and turn off my proxy. So something you might be able to do is just use the kind of strategies you would put in a parameter. So if I were to say like username is not equal to Gabe, and I'll do it for password as well. And so this is technically operator injection that we're doing here. We're just injecting our own operators into the query. And you'll notice it, it gives us a 302. It like lets us log in. And it's even redirecting us to, let's just follow it and see. There's this page called home.php. And there's really nothing to do here, but you can see it logs us in as admin, which, that's a username right there. So let's just go ahead and see if we can maybe get the usernames or the, password for that guy. So we could try, instead of username NE, we could just say that it's username admin, and we could do some like regex stuff to try and catch this. So I think we can do regular expression, and we can say, I think we have to do something like, I think it's, let's just do A. I think that's enough. Maybe, maybe not. Let's try this. Or maybe up, star. I thought it was up T dot star, and that should be okay. Oh, no wonder. Goodness. Okay, let me see if this is okay. Okay, cool. So you'll notice, right, if I were to type A, we get a 200, B, 200, C, etc. But when I type in T, which is the first character in his password, it returns true. That's because the query is now, instead of just looking up the contents of the password, it's saying the password is, anything that matches T and something. So it's, just doing this regex matching, which is really convenient for us, right? We could also do this with another username, which I think is better to do first, just because it'll kind of highlight my point. Let me just go ahead and copy this so we can mess with it later. Or we'll do, yeah. Let's do, and then for the username, we'll do the regex matching. And we can just go through every single first letter until we get one. Or it might even be faster. I'll just skip. You'll notice M is there. Well, the name of the machine is Mango. So it kind of makes sense that there would be a user called Mango. You get the idea. We could then use that in conjunction with our previous thing to try and brute force his password. And I'll just get the first character here manually, and then I'll turn it over to my script. Hopefully it doesn't take me too long. Okay, so we know the first character in his password is H. So let's just go ahead and try and brute force it. Now I've made a Python script for this that is definitely kind of overkill. So let me just go ahead and do Mango, and I'm going to change the length to 20 because I don't remember how long his password actually is. But basically all this does is it just crafts those post requests and sends them over. So it just parses through that first one, waits for a 302 response for something, and then gives it back. For whatever reason, I think it's busted right now. That's not the way it should be working. Let me see if I can maybe change the length and that'll fix it. Oh, I realize what's wrong. I have it set up to go through my proxy, so if intercept is on, none of those requests will get through. This will be fine. So, now it should just start slowly going through the password for whoever this, the Mango user is. So each time there's a 302 request, it just adds that character just like we were doing with the usernames and stuff, and it just slowly brute forces it. And this isn't really messing around with brute force protection because they didn't really have any brute force protection, to be fair, because they just brought you back to the home page with the 200. If they were doing rate limiting, we might have some problems, but in this applied review series, we've gotten around some basic rate limiting protections before, so it wouldn't be the end of the world. We would definitely figure something out, but this is just a nice little example that's pretty easy to go through, pretty straightforward, but it's just fun. It's all good fun. I think, yeah, so once it hits the top length, I don't think this is 20 characters, but yeah, there we go. And we can try to use this for SSH. And it works. You can see I already did some stuff on here earlier. But there's that. If we wanted to use it here, we could also log into the site. And you'll see it just brings us here. Or we just started farming. Contact us in the meantime. You get the idea. So that's really all there is to this machine. We'll go ahead and hop back into prevention and then we'll wrap up. So, yeah. All right, so prevention mostly depends on what's being used for a given application. Obviously, reading documentation can't hurt. Trying to lock down the application with the tools that are already given to you. But as you're kind of doing that, you might want to look for, trying to sanitize and validating user inputs with allow lists. Make sure that you're using parameterized queries to separate the data that's being input from the queries themselves. And then also try to use, an allow list of some kind of acceptable keys so that you're preventing potential operator injection. But that's most of what we got to go over today. It's a pretty short, sweet topic just because it builds on a lot of the concepts from SQL injection and other types of injection attacks. So that's all we got for today. I'll catch you in the next one.